All right, we're moving on, and we are now in section 1.4. So you've got 1.1 all the way to 1.3 overview. And now heads up, during class I might have you show me this for points, and if you don't have it, I can't give you credit for it. But we are now on 1.4. We're just going to kind of talk about, a little bit of the lesson. So this kind of gives you an overview of everything that we're doing. Anyway, whenever we have equations, and an equation is anything with an equal sign. So for example, when we have something like 2r, let me try that again. 2r minus 5 equals 10. We could absolutely try and plug in numbers. We can plug in numbers. All right, let me plug in 1. Let's see if that actually equals 10. Nope, let me plug in 2. Let me plug in 3. You get it. We can plug in numbers until we find out what r is actually equal to, when it equals what number it equals, so that the whole thing equals 10. But there's a process that we can use called solving equations that makes this job so much easier. So how do we solve equations? Or the question for today is, how do we solve for the unknown? The unknown is also known as a variable. And you've seen variables for a very long time, I'm sure. In fact, r in this case would be a variable, but x is often solve for x. You're solving for that variable. All right. So we're moving on. We're going to start this process. We've got to get good at solving equations. We've got to get good at this. Because from now on until you graduate, you will be solving equations. That's all there is to it. And so we'll start slow. We're going to do one step at a time. And in this case, we are doing one-step equations. Okay, this first part, again, this is the beauty of having an online class like this. If you don't know what the multiplicative inverse is, or the additive inverse, which I know you've seen in junior high, and actually you use it all the time, pause the video, and I want you to look it up. Just Google, what's multiplicative inverse? What am I multiplying by that would be the inverse of 1/2? Or what do I need to add to 1/2 so that I get a certain type of value of 0? But I'll let you figure that out. And the same thing for number 2. So when you do your notes, I'm going to look back to see if you've looked these two definitions up and answered those questions. All right, I talked a little bit about what a variable is, and the key to that is isolation. You're going to hear me say that. Get the variable by itself, solve for the variable. The mathematical term would be isolate the variable. And so when I say isolate, I'm just saying get the variable by itself. Okay? This next little project here, on your own, we're just going to see like past tense. I've isolated, isolation, I am isolating, or I'm going to isolate. How would you use those words to best represent these 3 phrases or these 3 sentences? And then jump down to number 4. So go ahead and pause your video, fill these in on your own. Tell me which word would best fit that sentence. Jump down to number 4. It's asking which one of these equations is the variable already isolated, meaning which one is, in this case, they all look like x. Which one is x by itself? Notice this one. X is definitely not by itself. It's not the only thing on one side of the equal sign. That's what it means when it's isolated. But if you jump to this guy, notice how x is the absolute only thing on that side of the equal sign. So we would say this is already isolated. Looking here, is x isolated? No, there's this 3 that's attached to x. It's not isolated yet. Jump to the last one. Even though x is on the right side, there's nothing with x. It's just x equals. And so in this case, we would say, yeah, that's definitely isolated. We have this thing called the addition and subtraction property of equality. Now, it sounds weird, but to be honest, you do this all the time. Okay? So if A equals B, if I add, so I'm jumping to this section right here. If I wanted to get this age-old thing, what we do to one side, we have to do to the other. And that's kind of what all of these properties are dependent on, is what we do to one side of equation we must do to other side. All things that we do from now on is because of that. So we balance an equation. Here in this little example, if we add c to one side of our equation, notice our equation with the equal sign, I have to add c to the other side to balance that equation. Here, this is just a nice little example. And we're isolating a variable. If I wanted to get n by itself, I would need to move -7. I need to make it the additive inverse. So what happens when I add positive and -7 together? They cancel, and I'm left with n, but I can't just do it to one side. If I added 7 to one side, I'm also going to have to add 7 to the other. And in this case, we can go ahead and solve 7, 8, 9, or in this case, 19. Same is true with subtraction. If I subtract on one side, I have to subtract on the other. Little example here, to get n by itself, we have to get rid of that +8. Well, if it's +8, to cancel that, I'd have to subtract 8 from +8. +8 minus 8 are going to cancel to 0, leaving me with n, but I can't just do it to one side. I also have to subtract to the other. So 9 minus 8 is 1. All right. Here we go. Our first problem, and let me just make this easy for you. Watch this. We're just going to work this together. Over here on the side, I've given you room. We are trying to isolate the variable. First of all, where is the variable? Isn't it y, or unknown? I don't know what y equals yet. Could I plug in values until I see which one of these equals -6? You could, but let's move beyond that. So to get rid of +2, I need to make it 0, so I will subtract 2, because +2 minus 2 cancels. But I can't do it to one side without doing it to the other. And so I do have y by itself, it's isolated. And we have -6 minus 2. Now, a lot of people have problems with negatives, so I like to think of a number line. And guys, I'm teaching this to juniors right now, where I'm starting at -6, and I'm going -2, or 2 in the negative direction. So if you think about that, if I go in the negative direction, don't things get negative as we go to the left of 0 on the number line? So if I go 2 more this direction, I would end up here at -8. So if you're one of those people who have problems with adding negative numbers, I promise you, if you just do a number line on a couple of those problems, especially after today's lesson, you could break through that barrier. I see it with so many students, so many times. Adding negative numbers, it hasn't clicked. If you'll do a number line and you'll start here at the first number, whether it's positive or negative, and if you're subtracting, we go to the left, and if you were adding to, you would move to the right, and then you can use that to help you see what number you're going to land on. You will overcome that, I don't really add negatives very well, that stigma. So let's just get over that. All right, multiplication, division, the same idea, all depends on keeping things balanced. So if I multiplied by C on one side, I have to multiply by C on the other side. Why would we ever multiply? Well, let's look at this example. X is not quite by itself. So I've got to get 5 out of what's called the denominator, the bottom. It's in a division type spot. What is going to cancel with 5 being on the bottom in the division spot? Well, if I had a 5 on top. Isn't that true? If I had a 5 over a 5, won't that always cancel the 1 for any fraction? If I had 2 over 2, that equals 1. Guess what? If I had x over x, that cancels always to 1. So whatever the denominator is, if I just have the same number on top in the numerator, look what happens. Oh, well, 5 will cancel with 5. But to balance this, I can't just multiply the top by 5 on one side. I also have to multiply the top by 5 on the other. I'm doing it a little different than, no, I'm not. I'm doing the same thing right here. Yeah. And so what would we get? Notice 5's canceling. We get x isolated. It's by itself, but 10 times 5 now being 50. Right on. And the same is true with division. Why would we use division? If I divide on one side by a number C, I have to do it to the other. This is the one you'll see a lot of times, by the way. And again, looking at this problem, I got x, it's so close to being isolated. If I could just get rid of 6. Well, what's going on between 6 and x? What happens when we have two things next to each other? If I wrote a 2 and a 6 right beside each other, notice that's multiplication. And that's true whether it's 2 and 6 or if that was 2 and x. 2 and x are being multiplied. Here 6 and x are being multiplied. So to get rid of a 6, let's divide by 6, which you see here. And here we are again, same number on top as on bottom, so they're going to cancel. Again here, same number. If I divide one side by 6, I have to divide the other side by 6. And we do isolate our variable. Notice x is by itself. And we can simplify 30 divided by 6. What is 30 divided by 6? 5. The key for all of this is what you do to one side, you have to do to the other. The hard part is, what do I need to do to get x by itself? That's going to be the question for every single problem that you're going to have to ask. What do I need to do to get x by itself? Let's try some examples on that. Again, guys, we're going to do our own thing over to the side. If I've got 10, so you don't have to fill this out for credit. This is what I want to see on your notes, is what we're doing right now. I'll let you know what you need to fill out. And if I say you don't have to fill it out, they don't have to do it. All right, check it out. X is not quite by itself because it looks like it's being multiplied by 15. Well, if it's being multiplied by 15 and I need to get rid of it, guess what we need to do? We need to divide by 15 so that these top and bottom will cancel, and I'm left with just x. I've isolated the variable, and that's it, right? I'm done. No. because what we do to one side, we always have to do to the other side. And so I do get 10 over 15, but as we get better and better at this, what do you notice about 10 and 15? That is a fraction, but they can reduce. It looks like the greatest common factor between 10 and 15 is 5. So I can divide 5 by 10 by 5 to give me 2. I can reduce 15 by 5 to give me 3. This would be my final answer. Try it again. Again, don't do it. Here we have 19 equals r divided by 3. Remember, I talked about we're not going to use that division sign anymore. We're not really looking at that much, but we are looking at this. If something's being divided by 3, in order to cancel, I need to multiply by 3. And I like to say more specifically, I like to multiply the top, the numerator, by 3. So that 3 on top and 3 on bottom are going to cancel. But if I multiply to the top by 3 on this side, I have to multiply to the top by 3 on the other side as well. All right. And so here we do have r by itself. It's isolated. And we've got, 3 times 19, which is, I believe, 57 when I multiply that out. Good. Again, don't. We're just going to do it together. And if you're wondering why not, it's because I could just say, here's the notes, go. And I've got all this set up over here so that it'll walk you through it, but I want to walk you through this to make sure we're good, okay? You can fill this out on your own if you wanted to, but I'm just letting you know right now, you don't have to. We're working it together right now. This is interesting, all right? Because notice there's kind of two things that are happening here. One, we're multiplying by 3 on top, and we're dividing by 4 on bottom. And I could break this into two different problems, where one, I get rid of the 3 by dividing by 3, right? If 3 is on top, that means I would divide by 3 to make those cancel. And we could do the problem and then do another step, but I can do both steps in one by what's called the multiplicative inverse, flipping it. So the 3 over 4, if I multiplied by 4 over 3, notice everything will cancel. 4 on top, a 4 on bottom, they're going to cancel with each other. And look what's left. I've got x. So is that my answer? X equals 12 and I'm done? No, because what we did to one side, in this case, multiplied by 4/3, we have to do to the other. And I know what you're thinking, fractions, but multiplying fractions is fun, all right? I promise. The more you do it, the more you realize, it's not that big of a deal. What I like to do when it comes to multiplying fractions is I divide first. So notice 3 is on the bottom, so it's division. Can I divide 12 by 3? Technically, this is 12 over 1, right? We don't really write it like that, but that is what is going on. And so if I have a 3 on bottom and a 12 on top, I can divide 12 by 3, giving me 4. Is that right? 12 divided by 3 does equal 4. And now look what I have left. All I have is a 4 on top being multiplied to a 4 on top, which 4 times 4 is 16. Is it still over 1? Yeah. But do we ever write our whole numbers like 16 over 1 or 7 over 1? Usually we just write it as 16 or just 7. And so that would be your final answer. All right. Tell you what I'm going to do for you guys. Let's not do this problem. So if you're following this video and you're listening and not just trying to do the notes and everything on your own. You just lucked out. I want to get to the homework so that we can give you plenty of time to get this done. All right. Jumping into the homework real quick, notice it's a lot like what we just did. Like number 6, if I wanted to isolate that variable, I would have to, positive 5, so I'll subtract 5. It won't cancel if it's positive 5 and I say plus 5. Wait, that's 10. So I need to make it 0 so they completely cancel. If I subtracted 5 on one, I have to do it to the other. And therefore, I would get what? This is another good. Wait, negatives. Oh, I hate those negatives. Let's go ahead and just start real quick in case we're having problems. Let's start at -1. And I'm subtracting 5 from that -1. So what direction would subtraction take me? Left or right? Notice if we're subtracting or going negative, we're going to go to the left 5 since it's -5. And if I'm starting here at -1 and I go 1, 2, 3, 4, 5 this direction, where do I actually end up? It looks like -6. Again, do this. If you're just tired of not understanding how to add negatives, do this on a couple of your problems, because then what happens is mentally you'll visualize this. And then over time, you'll start to understand certain rules that your brain will come up with by visualizing that over and over again. Okay? Again, same thing through the next section. We're just trying to isolate the variable. Here, if we're dividing by -3, guess what we have to do to cancel that? We need to multiply by -3. Not just 3, but -3. These would cancel. Multiply by -3. If I did it to one side, I have to do it to the other. And so we have negative times a negative is going to give me a positive. Notice y by itself. And 3 times 9 is 27. All right. Again, more solving. There's a couple word problems. I believe, let's look at the next page because there's more on the next page too. We could look at that. Let's just look at 21, kind of give you an idea of how we're going to do this. The profit of the company is 3 times, let me move this out of the way, 3 times the profit earned in the first year. This is what they've earned in the 5th, that's supposed to be year of operation. What is the profit in the first year? Oh, I'm sorry. So in the 5th year, we earned this much money. And that is 3 times what we made the very first year. So we don't know what this first year of operation is. What is the first year? I don't know. And anytime I don't know something, I don't put a question mark. I put X because it's unknown. What do we know? Notice here we have a total. I love finding, all right, when it comes to word problems, I'm always like scanning, where's my total? Boom. There's a total right there because I know, at least if I don't know anything about making the equation, I know that it has to equal the total. So I always go through and I label up, there's T for total. This is the X for the unknown. And here's another piece of information about being 3 times. All right. So I've read it, and what I've comprehended is that this value is 3 times what we made the first year. But I don't know what I made the first year, so we called that X. But we do know, in order to get this value, it had to be 3 times what we made in the first year. So if I multiplied this side by 3, what we're saying is that is equal to the 114,000. And even though it's a big number, it's the same process. I got to solve for this unknown. Could I just plug in values? Let me plug in 1. 1 times 3 equal 114,000. Let me try 2. So you can see it's going to take a minute. Or let's get x by itself. I'll divide by 3. If x is being multiplied by 3, I need to divide by 3. Here, I can't do it to 1 without doing it to the other side. So really, I've got x by itself. All I have to do is solve what is 114,000 divided by 3. Good old long division. 3 can't go into 1, but it can go into 11. What, 3 times? 3 times 3 is 9. So now I'm just going through long division. You can follow along with me. What is that? 9, 10, 11, so that would be 2. And don't we drop the next value down? What multiplies to 3 to give me 24? I believe that's 8. 8 times 3 is 24. When I subtract those values, I get 0. And then I could start dropping all the other values. But since all my other values are zeros, guess what? All these values are going to be 0 as well. So what we're saying is that first year of business, we made $38,000. How do I know if that's true? I mean, I'm done. This is my answer. Most of you are like, all right, move on to the next. But real quickly, if I just multiply this by 3, right? If we're saying in the 5th year it's 114,000, well, if I multiply this by 3, and if you go ahead and multiply that out, you will get 114,000. Just to check your answer. That's all that's for. All right, just a little guarantee that you're doing it right. And we're back to this. These are a little more challenging, trying to get in by itself, like number 23, because I throw fractions and decimals. But it's the same process. Here I have positive 2/3. So in order to move it, I'm going to subtract 2/3. Let me think. I'm thinking if I'm ready to show you a magic trick or not. This problem would not be a great one to start with. Yeah, it's not. So I tell you what I'm going to do. I'm not there yet. We're not there yet, guys. I'm going to show you a college level. I didn't learn it until my instructor showed me to get rid of all fractions. That trick alone that I will show you eventually, just not yet, is going to be worth it. This entire class, trust me. All right. So in this case, if it's positive 2/3, what I'm doing is I'm subtracting 2/3 to get in by itself. And so now I have to figure out what is 7/8 minus 2/3, right? And so just a review on fractions, we can't, multiplying, dividing fractions are awesome because you can just do it. There's nothing that has to be done, but adding, subtracting makes it a little more difficult because we can't add or subtract until we have a common denominator. And in this case, 8 and 3 are not. So we have to find the least common multiple. What's the first number that both of these go into? And in this case, it's whenever you multiply those numbers together to get 24. So, yeah, right? Let me double check that just mentally. Yep, that's true. Both 3 will go into 24. And both 8 will go into 24. So we're going to make our bottom, or our denominator, instead of these values, we're going to make them 24. But like an equation, a fraction, you can't do it to the bottom unless you do it to the top. How do I make 3 into 24 unless I multiplied it by 8? That's what I did here. I multiplied the bottom by 8. Wow. in order to get this 24. So I have to multiply the numerator, oh my gosh, by 8. Sorry about this, but it's just going to happen. Your computer gets laggy, things get a little sloppy, that's all. So I'm multiplying the top or numerator by 8. There you go. And what do we get now? We get 16. So I get 16 over 24. On the other side, what do we need to multiply 8 by to get 24? Oh, we had to multiply this by 3. So if I multiply that by 3, I need to multiply this top by 3. And now 7 is now negative 7 times 3, or negative 21. So I have negative 21 over 24. That looks sloppy. I'll just kind of write it over here just to make it look pretty, or prettier. And we said this side is 16 over 24. Now with the common denominator, we can go ahead and carry out the operation. Negative 21 minus 16. If you need to start at negative 21 on a number line, jump down here to negative 21. And if you're going to go 16 in the negative direction, come on, computer, you can do it. Notice we're going to get a pretty big negative number. And in this case, if I count 16 units in the negative direction, what I end up getting is negative 37. And I'm not done. Let me take that back, because this is a fraction. This is negative 37, but remember it's over the common denominator of 24. Wow, all that for fractions. So this last part's going to be just a bit challenging, mainly because it's fractions. All right, guys, we'll meet up in class. Hopefully you'll start on this, and we'll go over any questions you've got.